Hi, in this video I am going to explain what is mass transport. It is nothing but transfer of ions from one place to another place. Let me briefly tell you what is oxidation. Oxidation is a process where there is a loss or release of electron by the electroactive species, for example an ion or atom. Example is the atomic carbon undergoing oxidation by losing 4 electron, which leads to the formation of carbon 4 plus. And then reduction. Reduction is a is a it's a reverse of oxidation, where there is a process, then there is a gain or receive electrons by electroactive species, such as ion or an atom. For example, a ferric ion undergoing reduction by gaining 3 electrons to give atomic ion. Then redox, what do you mean by redox? It is a combination of reduction and oxidation. Uh, upon both reduction and oxidation, there is a passage of current across the two electrodes. This Due to the redox process, there is a change in the composition in the electrochemical cell. In this case, at this juncture, we have a reflection spot. Which electrodes are responsible for the oxidation and reduction reactions? Is there any flow of current across the electrodes? Let me pause this video and then try to answer these two questions. Okay, upon redox process in the electrochemical cell, the anode is responsible for oxidation and cathode is responsible for reduction reactions. Upon this redox behavior, there is a flow of current across the two electrodes, which results in the flow of ions from one electrode to another electrode for oxidation and reduction reactions. Okay, the magnitude of current, it's because the movement of electrons through the electrodes. So the movement of electron through the electrode solution interface, and then the movement of ions through the solution. These are the factors which are responsible for the magnitude of current. And the movement of ions, which is limited by the overall rate of charge flow. And the ions move from solution to electrodes for electron transfer. That is responsible for the transfer of electrons, and this is called a mass transport. And there are three ways the mass transport is taking place in the electrochemical cell. One is migration, another one is convection, then the next one is diffusion. I'm going to explain the three phenomena which is taking place in the electrochemical cell. The first one is migration. This is nothing but a movement of ions with respect to the applied electric field. For example, the cation move towards cathode and the anion move towards anode. Due to the electric field gradient, the ions are move towards the oppositely charged electrodes. I have already told you the cations move towards cathode and the anion move towards anode. The major drawback with this migration is the neutral atom or a molecule do not undergo migration. It is a charge dependent, and the supporting electrolyte also interfere in the transfer of in the case of migration. The next phenomenon is convection. It is due to the physical movement of the solution. For example, by using a glass rod in a beaker of solution, if you just physically stirring the solution leads to the convection. This can be minimized by not stirring the solution. Without disturbing it, there is a convection is taking place. So no stirring, no convection. So we can avoid. And the most important phenomenon in the mass transport is diffusion. And this is taking place due to the concentration gradient. This is the in the absence of convection and migration, this diffusion is taking place. The diffusion, I have already told you, the diffusion is taking place due to the concentration gradient. That means the highly concentrated solution transfer from, sorry, the highly concentrated ions transfer from highly concentrated to lowest part of the solution. The presence of electrolyte, it is 1,000 times greater than the ionic concentration. And let me thank you all for this.